Welcome to this video on using literacy strategies to build math skills. Math text is very often challenging for students. Terms can be confusing, formats can be confusing, symbols can be confusing. Here are some examples of terms that students may struggle with. Divide by as opposed to divide into, mean and median, sign and sign, sum and sum. Words that sound the same but are very important in math. Formats. We use subscripts and superscripts. We use different types of graphs. Clocks can be read on an analog clock or a digital clock. Symbols are often confused. Greater than and less than students struggle with into secondary school. Graphic representations. When do we use a certain format? When is it better to use a bar graph or a line graph? What happens when we change the orientation of the graph from the horizontal to the vertical? Math text also has challenges for students. There are more concepts in every sentence in a math text. The style is compact. There's not a lot of repetition. The information isn't always presented left to right. There are graphics that need to be interpreted, and the content is both numerical and non-numerical. Those terms of vocabulary can throw our kids because small words make a difference and they may differ in meaning from other uses that students are familiar with. There can be sidebars in a math textbook that provide review or extra practice or a connection to something else, and they're not directly related to the content on the page. So taking what we know about good readers and comparing it to good mathematicians can help us see why some literacy strategies may be helpful in teaching math. Good readers use prior knowledge. Good mathematicians use prior knowledge. Good readers are fluent in decoding. Good mathematicians are fluent in applying procedures. Good readers create mental images and use multiple strategies. Good mathematicians create multiple representations to solve problems. Good readers monitor their own understanding. Good mathematicians monitor their problem solving. Good readers interpret and can explain their understanding and their thinking. Good mathematicians can explain mathematical thinking. So here are some tasks that we ask students to do in mathematics, but they're very similar to tasks that they might perform when they're working on literacy. And so we might ask students to understand a process or an abstract concept and translate it into symbols. We might ask them to find patterns or decode words or symbols. We might ask them to translate words into a mathematical representation of a problem, or vice versa. We might give them the mathematical and ask them to translate it into words. We could use journals to think about our ideas and our thinking and our problem solving, and we may use writing to compare concepts. So in the graphic on the right there, what you see are three different levels of literacy, and that basic literacy is when kids are learning sight words and the very basic means of expression. Intermediate literacy is in elementary school when our students are building, they're expanding their vocabularies, they're expanding their literacy skills. But up at the top, disciplinary literacy, which is a smaller subset, it's much more specific in terms of vocabulary, in terms of concepts and processes and reasoning skills. So focusing specifically on vocabulary in math, we know that there are some general guidelines that are research-based for teaching vocabulary in any subject. One is that we don't want to focus solely on dictionary definitions. We want to give kids both linguistic and non-linguistic representations. We want them to see the vocabulary used in different contexts. We might teach word parts, especially helpful if we're talking about measurement systems. What's the difference between milli and killi and so on? We might allow time for discussion, let kids talk about that vocabulary. there are many stories that connect to math concepts. We can sometimes use literature to make those connections, especially for our elementary and middle school students. So 6 effective steps are to have students provide a description, an example, put the definition in their own words, draw a representation. They might have a vocabulary notebook where they can write questions and thoughts. They could discuss in pairs and small groups. You might even play games using the vocabulary words. So if you use a vocabulary notebook, here are some things that you might do. You can ask students questions that include the vocabulary word. So what does it mean when we talk about factors? How is that different than when we talk about factors that led to the Civil War or another topic outside of math? You might ask students to explain in writing. What strategy did you use to solve that problem? Why? Is there another strategy you considered? Do you think that might have been more effective? Or ask them to provide a rationale or make a prediction. How do you know the strategy you used worked? So how do you verify what you've done? What prediction can you make about the patterns you see? Word walls can be very helpful for teaching vocabulary, and word walls can use both words and pictures. They help students scaffold learning. So on the left, you see a word wall that's been created for math in an elementary classroom where it's fairly permanent. On the right, we have one for middle school where this may be a teacher who moves from classroom to classroom, and using the pocket chart is pretty easy to take with her to wherever he or she may need it. Here's an activity called Toss Terms. So if you use the net for a cube and you put processed terms to the sides of it, or you can use an existing box if you've got one. In small groups, students toss the boxes, and whoever catches the box has to use the word on top. So just a little fun way to reinforce some of their understanding. There are any number of games that you can play that reinforce vocabulary. Charades, Make My Day. Students have cards that have the vocabulary words or pictures or examples. You give clues, and the students who have it have to hold up their cards. I Have, Who Has. You give cards that say, I have, who has. The first student reads the question, I have, and fills in the blank. The student who has the answer has to stand up with the who has part. You might have students do a math hunt. You might have them, kind of like a scavenger hunt, create representations or find representations of vocabulary terms. If you have access to technology, you might have them make a Wordle or a tuxedo using vocabulary, but they can do it just as well with magazine pictures, anything that represents the terms. Talk a mile a minute. So this is a game where one student has a list of related terms, and the student, kind of like password, only they keep talking and talking. They're trying to get the rest of the team to say the terms. And then, of course, in the picture, there's vocabulary twister. So concepts. What do we want kids to do with vocabulary? We want them to have the academic language that allows them to develop concepts in math. And so when we're thinking about how to plan a lesson, we really need to consider, what's the concept? Where are students going to struggle with this concept? And what strategy can I use to prevent that struggle and to support students in making the concept? What do students already know? What have they learned that's going to help them connect to this idea? Does it connect to something in another class in school? Does it connect to their experiences out of school, to their interests? When they're constructing the concepts, we want to model the strategies that we're using so that students can hear them and see them. And for the comprehension piece, we want to make sure that we're using formative feedback from our students, we're assessing, and we're making adjustments as we're going in case there are students who were not making those connections and constructing a concept. And we want to give them time to think about the concept so that they're connecting their existing schema to this new knowledge that we're giving them. So here are some ways that we can focus on that concept formation, that conceptual understanding in math. Graphic organizers. There are probably hundreds and hundreds of different graphic organizers. You can do a quick web search and come across many of them. They provide a concrete way to represent something that may be abstract. They can show us the connections between different ideas. They can help us understand if there's a hierarchy or any kind of a relationship, whether it's cyclical or linear or spiral. Students can see how these different ideas fit together. We might use a double entry journal. In a double entry journal, and the key thing here is that you designate one side as the side where students are putting actual information. It can come from the text. If you're lecturing or giving a presentation, it might come from that. And so they put that key information on one side. On the other side, they write down their own thoughts, questions, connections, comments, analysis, and then you can take time and have them share their responses with each other. So it's a good way to get kids going beyond that procedural step and really thinking about the concepts behind the math, the understanding. This is just an example, and it doesn't matter if you designate left or right for what they are. Here, as long as one side, in this case the right side, is where the actual factual content was put down. On the left side, this is where students are reacting in some way. So they can predict, they can reflect, they can question, they can challenge, they can make connections, they can create a mind map. You know, it's only limited by your strategy, your thinking, and what you want kids to get from the content that you're teaching. This is just another example of a double entry journal, and you can see here we've got a student who drew a diagram to make sense out of information. If you're not familiar with this organizer, this is a wonderful one for both vocabulary and concepts, and the strength of the Frayer model is really something it includes that a lot of other organizers don't. So in this case, I could choose a vocabulary word that's something I strictly want my students to learn, but I could also choose a concept and put it where that word is. So on the top two quadrants, students are going to put a definition. The definition can be in their own words. It can be a dictionary definition. It can be a definition you give them. Characteristics. And then on the bottom, here's where this is the strength of this model. It's finding students generating examples and non-examples. They have to think critically to do that. They have to connect to their prior knowledge. And the resulting model creates a visual. It's a way that kids can refer back to it and have an ongoing tool to use to support them. So here's a math example. This one's for quadrilateral. So we've got a definition in your own words, facts, and then we've got examples and non-examples. The examples and non-examples here are written as words, but they could just as easily have been drawn. Here's another example for composite numbers. So we've got our definition, facts, examples, and non-examples. A Venn diagram. We don't often think of using Venn diagrams in math, and we typically use the two overlapping circles, but you can see here a variation of that. So if I wanted to represent visually for kids, it's a graphical expression of a relationship. I've got shapes here. And by looking at this, even if I'm not sure what all of these elements are, I can tell that squares, rectangles, and rhombuses have something in common. And all of them have the same characteristics that a parallelogram is going to have, and that's why parallelograms encompasses them. Trapezoids don't have anything in common with any of those other shapes. You might use a these are not charts. This is taking that bottom piece, the examples and non-examples from the Frayer model and just focusing on those. That's another variation you might use. You might use a semantic feature analysis, which is more commonly known as a matrix. So in this case, we've got an example of polygons, and we've got the names of different polygons on one side, and then we've got some characteristics about them. And we're checking off which characteristic applies to which polygon. Another graphic organizer is a concept definition map. Okay, so here I'm comparing it. What is it? I'm comparing it. I might include vocabulary. What are some key terms and examples? What is it like? Okay, so forcing students to think beyond that simple surface definition. You might also have students make mind map, and there are lots of tools listed here that are mind mapping programs that you can find online. However, this can just as easily be done on a whiteboard, on a piece of paper. And so it allows students to create a visual image connecting lots and lots of different ideas. So making connections, this is the key to critical thinking. And in math, we want kids to make connections to themselves. So we want them to connect the math skills we're talking about to their own life experience. And we can model this process. This is where number sense comes from, and this is the thing that often is lacking for our secondary students if they have been taught by teachers who are not comfortable teaching math and tend to teach it as procedural. We might also challenge students to make connections from math to math. So what do they know that they've already learned that they connect this to? Again, we can model it. We can do think alouds. We might use manipulatives. We can question students. And math to world. How does this connect to things that are happening in other classes or current events, things in the news? Where can we make math connections? When you're introducing a new concept or a new topic, you might use a 1-minute schema chart. So what you do is you give students 30 seconds, and as a class, we just brainstorm. So here, if I did it for fractions, okay, these are terms that my students came up with. Maybe I used the 1-minute schema chart and gave them the word coefficients, okay, and so I want to ask myself afterwards, all right, fractions. So students know lots of different things about fractions. They have an existing schema. They have something they can hook new knowledge onto. If I'm talking about coefficients, it looks like my students don't know much about coefficients, so I've got to build that knowledge if I want to use it. They know that co means with, but they don't understand what that has to do with the word efficient in any way that they know it. I might do a math stretch. This is for elementary, for lower grades, and I might ask, how did my family use math last night? And ask them to come up with as many ways as they can. I might have them share with a partner and then share with the group. This is such a simple idea, and it's such a great way to quickly get an idea of students' connections that they're making. So in this case, percentage makes me think of, and then students would use words, pictures, symbols, anything they can think of that would complete that sentence accurately, and they would fill it in. And it gives you a very quick read on what students have what understanding. Word splash is a fun strategy, and it's a good way to, again, reinforce or identify background knowledge, and you can organize a large group of facts pretty quickly, and it's just a little twist on things that you may be doing already that kind of builds interest and curiosity. So you select 20 to 25 words, and you splash them, which just means you write them on a sheet of paper in no particular order. And So students then have to draw lines where they're connecting the words, and on the line they're writing what's the relationship. And then you review either in small groups, whole group. And so here, these are words related to subtraction. So students would be asked to draw lines connecting things that they think belong together and explain the relationship on the lines. You might find that using anchor charts is helpful. A lot of times we tend to use anchor charts simply for strategies, but you can see from the one on the left, doing math. We've got real life and school, and they connect through problem solving. So this is more a conceptual anchor chart, but it can be posted and kids can come back to it and refer to it as they're working through things. Questioning is also very important in math, and questioning brings us to that higher order thinking. So mathematicians themselves question to clarify things. They've made predictions and they want to check if their prediction is true. They wonder what would happen if something changed in a problem. They might question to try and find the information they need to solve a problem. Or they may question a solution to see, does this make sense to me? So there are two types of questions, fat and skinny or thick and thin. And we want to ask students fat questions or thick questions, and we want to get our students used to asking those questions. So there are questions like, what if? Why did? What would happen? What would happen if? What would you feel if? And if you are interested in these types of questions for math, Laura Kendler's website has some great resources on this. So good questions in math, higher order thinking or open-ended. Open-ended meaning there's more than one approach, maybe even more than one answer. So questions like, list 10 possible combinations you could get with 4 darts. And the numbers on the target are 7, 5, 3, 1. But they're asked to focus on a logical method of doing that. You might ask, here's a great one. I know my middle school students would respond to this immediately. So decide if it's better to receive $300 a week or to be paid hourly at the rate of $7.50 per hour. And then what could impact or affect your decision? Here's another one. 3 watermelons and 2 cantaloupes weigh 32 pounds. 4 watermelons and 3 cantaloupes weigh 44 pounds. All watermelons weigh the same, all cantaloupes weigh the same. What's the weight of 2 watermelons and 1 cantaloupe? And the last one, Sylvester measured his pulse and found that his heart beat at a rate of 80 beats a minute at rest. At this rate, how many days will it take his heart to beat 1,000,000 times? And explain each step. And I would suggest that using questions like this, I would encourage students to look for variables that might impact the answers. There are questions called questions for purposeful learning, and you start with a prompt, and then students come up with questions. You share the questions, and then either present the information, read it in the text, talk about the answers. So here's an example of a prompt from math. I can tell you the distance around the world with just a ruler. So you might post that on the board or display it, and then have students create questions, getting them to think about that concept. If you want students to synthesize information, a couple of visuals that can be helpful with this. Nesting dolls. If you line them up, and ask kids, how do they represent your thinking? You stack the dolls together and ask them again, what does that tell you about your thinking? You might think of the idea of a visual of making a cake and mixing the ingredients being a way to synthesize ideas. You might ask students to make conjectures about classes of numbers, procedures, outcomes, properties. All of those support higher order thinking. Monitoring comprehension. Here's a very quick and easy way to do it. Two different ones. One is to have a trifold board. One side has the word huh with a question mark. The other side has a light bulb, and you just ask kids to put it on their desk or sit it up. Exit tickets and color-coded metacognition. So you have sticky notes. You use 3 different colors, and one represents good understanding, one represents confusion, one represents being clueless, and then the students have to write a reason why. They can't just give you the green note, but they have to write a statement on it explaining why. If you see that your students are not making connections, can't visualize, their mind is wandering, they're not remembering details, or they're not finding answers, they may need a checklist that helps walk them through. Anticipation guides. I love anticipation guides. When you're introducing a new topic, it gets kids thinking about it critically, and it's usually pretty quick and easy to do. You just have 4 or 5 statements, and students write whether it's true or false, or they agree or disagree. And then after the lesson, you come back and revisit it. So here's a math example. This one's on decimals. So we've got 3 statements on decimals. Kids mark agree or disagree. We do the reading. We discuss it. They come back and say, okay, do I still have the same thought? Writing is a great way to support critical thinking in math. Journals, you can give them prompts. They can free write. You can do quick writes, mathographies. They can write about problems. They can write formal papers. They can write questions. And why would we want kids writing? Because it clarifies, it reinforces what they know and allows us to see what they don't. It connects to prior knowledge. It's a way to summarize. It's a way that they can ask questions without any negative connotation. It's a way to reflect and to build meaning. So here's an example of a mathography. Just someone's story of their experiences with math. How to start? You can start small. What went wrong with problem 3? Describe what we did in class today. On the back of the homework assignment before they hand it in, what did you learn? What was confusing? Have students summarize something they've read. On a test, ask a question about a definition or a process. How do we subtract integers when the signs are different? We might use sentence starters. Math is like, factoring is easy if. Okay. Journals, a way that every student can communicate their thoughts and feelings, and they have a record of their learning. What are you thinking? Explain this process for someone who's younger. What does the formula mean? Why does this step make sense? Okay, so you can ask them questions. Quick writes. Quick writes are another good way to get kids thinking critically. 2 to 3 minutes. And you can post a saying or a quote or a prompt on the wall. In this case, infinity is a floorless room without walls or ceiling. And then the question is, do you agree or disagree? Students do not have to write about the prompt, but they can. And after 2 or 3 minutes, and you're writing with them, after 2 or 3 minutes, have a couple of people share them. It stimulates that deeper thinking. Gives them choices. Okay? It builds confidence in writing because it's short. It's only a couple of minutes. If a student is absolutely telling you, I don't know what to write, I can't think of anything, have them start copying the prompt. It gets pretty boring really quickly and they start to think. So thank you for your time and attention. And as always, if you have any questions or concerns, please contact Teacher Success.